Alright, hell yeah. So we're going to try to do every statics problem. You know what I mean? And this is, I love these first chapter problems. You know, I could do these for the rest of my life. But anyway, this is F equals MA problem. And, you know what I mean? I got to make these videos short. But this side of the equation is what you measure. You know what I mean? I would say in this case, you measure it with a scale. And in this side, the acceleration is what you see. Do you see motion? You know what I mean? Do you see motion in the ocean? Anyway, so it says on the moon a person weighs 30 pounds. So you brought a scale to the moon and it said 30 pounds. Well, guess what? That's that side of the equation. Okay, and then they just give you, so either you're gonna observe, you know what I mean? So then if you had a rock on the moon and you dropped it, you could get this, you know what I mean? That's where I got to make this video short, because we could just go on a tangent and start figuring out why this is the gravity on the moon. But I will write Kepler, you know what I mean? Said, hey, the force of gravity is G, you know what I mean? Whatever the two masses are, and then the distance between them, and then a gravitational constant. And so this goes into this side of the equation. You know what I mean? And then so that's the other thing. And we got to get to it, because like I said, this is for another video. You know, we just want to make this simpler. So they just give you the acceleration. Okay, so now we know the force is 30 pounds. The acceleration is 5.32 feet per second squared. Well, guess what? We have two knowns and one unknown. It's the mass. So how do you want to do this? Do you want to rearrange this equation? Let's do that. So, I mean, how much do you need to do? Sometimes your mind don't work and you're just like, okay, I'm going to flip these and then I'm going to go MA equals F. Perfect. And now I'm going to bring the A to the other side downstairs. So now we're going to go M is equal to FA. Else, you can just say, hey, I just want to isolate M, and M is equal to FA. You can just do it in one step. But anyway, once you get this, M is equal to force over the acceleration, toss it in. So we have 30 pounds divided by 5.32 feet per second squared. And what the hell does that give us? 30 divided by 5.32. Alright, it gives us 5.639. You know what I mean? Just start. And we're going to, I always like to store it in my calculator as a letter. So then we know like it to 10 digits. TID, whatever it does to 10 digits. Alright, so we got that. Now what's the units on this? And it don't make sense anyway. So right here, we will take a step back and be like, hey, F equals MA. Okay, so what are the units on here? Let's use the SI units, because it'll make more sense. Force is in newtons, and then mass is in kilograms, and then acceleration is in meters per second squared. So this literally, and sometimes I write it like this, you know what I mean? Units, kilograms, and then meters per second squared. Okay, because the units is the equation. That's kind of the take-home point for this first video. And so if I want to know kilograms, well, I just take newtons and divide it by meters per second squared. Okay, so this is the SI units. And here's the trippy thing, because in the U.S. customary units, it don't make no sense. Pounds make sense. Okay, hell yeah. But this is called a slug. Like, it's crazy. Never in my life, outside of a textbook, has anyone ever used the word slug ever. But tons of people use kilograms all the time. Grams, kilograms. No one's ever used the word slug. But the U.S. customary units, this is kind of the... Anyway, and maybe we will go into this just a little bit. And then your acceleration is in feet per second squared. Okay, so now the units are the equation. So there you go. So you got slugs and then feet per second squared. And we will use another sheet of paper for this, because this is just really important, because there's other problems in this first chapter that will use this concept, and it's just, you need to, okay, so now that we know that I'm going to say it one more time. The units are the equation. So now we know that 1 Newton is equal to 1 kilogram times 1 meter per second squared. Cool. So this is totally correct. And but on Earth, you'll find that our acceleration isn't 1 meter per second squared. It's 9.8 meters per second squared. So now what gives? What gives? Well, let's say we still use that 1 kilogram. Well, now over here the equation's got to be balanced. So you have to get 9.8 newtons. So this is a really good one to do and to be like, oh, if I'm on Earth, the acceleration of gravity is 9.8 meters per second. We all know that. You know what I mean? G is 9.81 meters per second squared. Or just acceleration of gravity, 9.81 meters per second squared. Cool, got it. But that means that if you have that standard mass of 1 kilogram, it's going to weigh 9.8 newtons. Now here's the crazy thing. I swear to God, most people are just like, well, what's a newton? Well, 1 newton is just a quarter of a pound, 0.25 pounds. Now, I graduated college, and that's all I knew was, yeah, newton's a quarter pound. If I want to convert newtons to pounds, all I did was just be like, oh, okay, so 1 newton, what's the conversion? I want to convert 1 newton, and I'm just going to go 1 newton is 0.2, and is it more than, is it less than a quarter pound, or is it more? I have no idea. I think it's just less than. It says 2.449, 2.448. Anyway, I just memorized this, which was silly, because right here it actually gives you. So anytime you're trying to convert newtons to kilograms or newtons to pounds, use this. You know what I mean? Say, hey, F equals ma. The acceleration of gravity is 9.8, so we'll put that on that side. And we're going to have 1 kilogram, and then we're going to have 9.81 newtons. So now we can basically, and this is just Earth. You can say, hey, this is Earth, but on Earth, if you have a mass of 1 kilogram, you know what I mean, it is just going to weigh, it's going to be equal to 9.81 newtons. Okay, so now you're just set. So now, if you wanted to convert newtons to pounds, and I'm sorry, we're not even doing the problem, but this is real important. Okay, so if you're going to convert newtons to pounds, well, let's say I don't know, like how much do I weigh in newtons? I weigh 160 pounds times 4. Hey, let's say I weigh 640 newtons. How do we convert this? Well, you can know from here that 9.81 newtons is 1 kilogram. And then you can go 1 kilogram is equal to 2.2046 pounds. And I think this is a long way to get to it, but I think this is the only number you should need to memorize. Everyone knows this is 9.81. That's really close. But then, you know, one kilogram, yeah, it's 2.2 pounds. But if you want to get more accurate, how do you get more accurate? Well, you say 100 kilograms is a metric ton, and that's going to be 2,200. But it's 2,205 pounds. You know what I mean? It's pretty close. But it's 2,204.6 pounds. You know what I mean? Maybe you can memorize that. You know what I mean? It's a 5, but then it's 1 less, and then, yeah, points. Anyway, but this is going to be your easiest way to convert newtons to pounds is to memorize this. Alright, so we need to take a break and maybe print out another sheet. Alright, holy Toledo. Let's do another printout. And I swear to God, like, my videos are too long, but we're going to do it. So anyway, what the hell was this all about? Well, it was introduce this component of slugs. And we learned about the SI units of kilograms and how a kilogram is related to a newton. So now we actually want to know how a slug is related to a pound. So let's do that. Let's write F equals MA again. Let's write pounds. Let's write slug. And then let's write feet per second squared. Now, if we're on Earth, the acceleration part is 32.2 feet per second squared. So just like we said 9.81 and we had 1 kilogram, that's going to be 9.81 newtons. You know what I mean? And let's do that one more time. Oh my God. There you go. We have 9.81 newtons. Now let's convert that. You know what I mean? That's why I wanted to do my weight in pounds. It's 640 because, you know, it's a new number and it's a large number, and then you can convert this and we can do that. So we can take 640 divided by 9.81 times 2.2046, and then you get 143.8 pounds. And the reason why this it isn't my weight is because it's like 4.44. That's another, you know what I mean? If you want to know exactly, there's two ways to figure out how many newtons are in a pound. One is Mike Tyson. Mike Tyson weighs 225 pounds. Everyone should know that. You know what I mean? If you don't, now you do. Okay, so 1 Mike Tyson is 1 kilonewton. And that's 1,000 newtons. So 1,000 newtons is 225 pounds. It's a Mike Tyson. Hell yeah. So that means 1 newton is 0.225 pounds. Now, if you want to get hella more accurate, I don't know. So then the other one is I just know that if you just do 4.4 just repeated, you know, on repeat, that's how many newtons it takes to equal 1 pound. That's the two thing. I know Mike Tyson is 225 pounds. And then I know, and I think if we actually do this, it's 224.8 pounds. You know what I mean? So it's 0.2248. I think that's a more accurate number. But let's do it. If I just remember 4.4 on repeat, or actually just 4.44, call it good. If newtons is equal to 1 pound, then I can get 1 pound. I can just divide by 1 divided by 4.44, and what the hell do we get? 1 divided by 4.44 is we get 0.2252 pounds. So yeah, that's not quite accurate. So that's where I think this will do it for us. So anyway, so we have newtons, and now we want to convert this to pounds. I know 9.81 newtons is 1 kilogram. Now, how do I know this? It's crazy. It seems like a redundant equation, but if I know F equals ma and I'm on Earth, I know this is 9.81 meters per second squared. I know that if I have 1 kilogram, then I got 9.81 newtons. So from this relationship, I can get 1 kilogram is equal to 9.81 newtons. So I can use this relationship. That's what we get from this equation. So yeah, there you go. And anytime you have an equality, you can stack these. 1 kilogram, 9.81 newtons. It's a ratio, and you can flip-flop it. It just depends on what you're trying to do. If I have newtons on the top, I got to put newtons on the bottom, and then now I got kilograms. So hell yeah. So now I have 1 kilogram. That's exactly what this says, is I got 1 kilogram now. But I want to convert to pounds, so I go 1 kilogram, and I know that's going to be, 2.2046 pounds. And this is hella accurate, good enough. You don't need to know it to any more. I think if you do know it to any more, I think it's like 2.204622 pounds, and then I swear there's probably like a 9 here, so it's probably like 0.3 or something. I don't know. Anyway, but anyway, it's going to be close enough. So now we're going to get, this is just 1, and then yeah, you're going to get 9.81 newtons is 2.2046 pounds. So now, if we wanted to know what 1 newton is, so 1 newton, let's do that, is 1 kilogram, 9.81 newtons. Newtons cancel, and 2.2046 pounds per 1 kilogram. And then we get 2.2046 divided by 9.81, which is 0.2247. You know what I mean? Good enough. You know what I mean? 29. And I think this might be closer to an 8, but who knows? You know what I mean? It's good enough for what we want. This is hella accurate. Hella accurate. And plus it's 729 anyway. So if you throw that into your calculator, So anyway, holy Toledo. All right, let's get back to the problem. So, but now we can actually figure it out. So we can say F equals ma. We know the force is 30 pounds. And we know the mass. We don't know the mass, but we know the acceleration is 5.32 feet per second squared. We do know that in U.S. customary units, pounds is equal to slugs feet per second squared. So there you go. So now we have pounds and we have the feet per second squared. So this will give us slugs. So if we take 30 divided by 5.32, it's just going to give us the number in slugs. 30 divided by 5.32 is 5.639, blah, 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 whatever. It's 5.6 or 5.64 slugs. Okay. Okay, but now let's talk about significant figures. They only give you 2 digits there. They give you 3 over here, but you have to take the lesser. You know what I mean? So we can only use 2 digits in our answer. So we're going to go 5.6 slugs. And you'll see in a second that there's plenty. Because no one ever says, hey, I weigh 30.2 pounds. No. But it is sometimes for measurements, though, you know what I mean? You don't want to compound your error. So if you know gravity to a decent decimal place, yeah, you always want to use as many digits as you significantly know in your problem. But then 1 just might be a total guess. You know what I mean? But don't round every. Sometimes it's best not to round everything. Okay, all right. So now we actually want to know maybe like how much a slug weighs. You know what I mean? But if you say like how much does a slug weigh? Well, on the moon, you know, 30 pounds is 5.6 slugs. I can't even do math right now. So let's do the second one because, yeah, then we'll figure it out. So what's the weight of the person on Earth? So let's do F equals ma. The A changed. This measurement of the scale, well, we had the scale on the moon and it was 30 pounds. But now we took the scale to the Earth and we don't know. We don't know how much the scale will read. But we do know what their mass is. And the mass doesn't change. So that's the name of the game. Mass just means like, hey, that's how many molecules occupy your body. And whether you take them into a black hole or onto the moon or onto the Earth, you're going to have the same number of atoms. And we're gonna call that mass. Just the number of atoms, that's going to be your mass. Anyway, so that doesn't change. And we found out that 5.6 slugs is a mass unit. You know what I mean? No one's used slugs ever. So if I say I weighed 72 kilograms, you know what I mean? I might weigh pretty close to 5.6 slugs, and I just never knew it. Okay, so now we'll do it. So now we want the force in pounds is equal to 5.6 slugs. And then we know the acceleration of gravity on the Earth is 32.2 feet per second squared. That's the U.S. customary units. And there you go. So we got 5.6 times 32.2. And we'll use like the, you know, we stored this into our calculator as A. So we're going to do, you know, whoa. Alright, hell yeah. So let's do it. So 32.2 times this, you know what I mean, value, 5.6 slugs, and we get 181.5789, blah, blah, whatever. We'll store that as B into our calculator. But anyway, and this is pounds. So we get 181.5 pounds. Now, anyone ever tell you that they weigh 181.5 pounds? No. Does anyone ever say they weigh 181 pounds? No. Anyone ever say, hey, I weigh 187 pounds? Hell no. They're either going to say 190, 185, or 180. You know what I mean? That's how many pounds they're going to tell you weigh. So that's why here you only have 2 significant digits. You know what I mean? So for the answer of this problem, it's 180 pounds. You know what I mean? So how much does this person weigh on Earth? 180 pounds. Cool. Okay, and that does it. And anyway, and I'm glad I went over this, but I have a hard time making short videos. Because I go on tangents, and I'm just not prepared for them. But I think I do a good job of explaining. So, alright, let's just friggin' A. Thanks for joining me for this one. Let's get on to the next problem.